Hello everyone, my name's Rhys. I'm the founder of FlowLedger. I'm just going to share my screen and get the show underway. Right. So FlowLedger is it's a new product. It's a web application.
You know you're not shared, right?
Are we not?
No.
Hang on a second. Oh, we will in a minute. That was just a dry run.
There you go. I'm looking at Windows.
Now you're looking at FlowLedger.
Hey, okay.
So a brief hiccup, and we are time bound, so I'll make it up. Don't worry. Yeah, FlowLedger it's a new product. It's a progressive web application. What we're trying to do, we're trying to move into something we term dynamic project planning. So engaging everyone in the project in project delivery. So I'm going to apply some context into why FlowLedger is required in the construction industry. Some of the audience will be familiar with this modernize or die strapline from the Farmer Report, which is published back in 2016 at the government's behest. In it, Mark Farmer identified wide-ranging failings in the construction industry. Amongst the critical symptoms of failure, there was low productivity, low predictability, low margins, and poor industry image. So these are the ones I've highlighted because these are the ones I believe FlowLedger is addressing. And this is backed up by some fairly startling statistics. These are from McKinsey & Co. Consulting. 98% of mega infrastructure projects suffer cost overruns of more than 30%. 77% of which are at least 40% late. Now, I spent the last 5 years of my career planning sections of HS2 with a combined estimated value of around £9 billion. So to put those figures into context, that's a predicted £3 billion overspend on those sections of the route, and they're going to be delivered into service 2 to 3 years later than currently forecast. Clearly, this is an untenable position. And it leads me on to the next statement. Projects are out of control. I think there's overwhelming evidence to support that, and an overwhelming requirement for something to be done about it. So we propose to fix things with Lean Six Sigma. From parity in the mid-90s, productivity in manufacturing is nearly double that of construction now. So we've been researching the productivity tools used to drive this success story and create a new, unique variant tailored to the requirements of our industry. And what is Lean Six Sigma? Well, it's a synergy of two concepts. Lean seeks to eliminate waste. Six Sigma eliminates defects. And both can be applied to the DMAIC standard improvement model, which is traditionally associated with Six Sigma. DMAIC stands for Define, Measure, Analyze, Improve, and Control. It's all about continuous improvement. If you'd like to know more about this model and how it's applicable to the construction industry, you can visit our website. That's flowledger.consulting. But more importantly, we're going to talk about how we apply this fix with the app. So the first thing we need to do is create a stable system. To do this, we take a copy of the master program. Currently, we support Primavera P6, so we're taking an XER file, but we're working on developing support for MS Project, Aster Power Project 2. If there are any other platforms the audience are using and they'd like to get on board with FlowLedger, please drop it in the comments section and we'll take that on board. But this is going to give us a snapshot of the project system. I'm going to bring that up now. Again, many of you are familiar with project controls and indeed the construction industry will have seen one of these before. It's an S-curve, or two rather. So you've got the life cycle of the project at the bottom, the percentage complete of the project, and we're bounded by early boundary and late boundary. So the earliest is the cumulative tasks complete at the logical earliest start, and then you've got the late boundary, which sucks up all the float. And in the middle, you've got your project system. If you deliver within this system, you're going to be delivering the project on time. Now, you may have noticed I've got a question mark against early boundary. And this is because typically This isn't the true early boundary. There is a level of pessimism inherent in a task. In NEC, it's termed time risk allowance, and it's actually mandatory to include that allowance. So it's your most likely duration rather than your best duration. So you're immediately, the contractor's banking float there, actually. It's quite a neat trick. But you also have resource linking in there rather than true logic linking. So you've actually got more float in the schedule than you think. It's an interesting aside, but we take the snapshot. What's important to us is developing a stable system, because stable systems exist in manufacturing. You imagine a production line. They don't typically exist in construction. So we can adopt a stable system by using the float between the early and the late boundary. Now, this allows us to calculate the shortest path through the project system. This establishes what we call a racing line, which allows us to do the minimum output while still achieving the project goals. Now, less work in process means work gets completed quicker. So you'll actually start to buy time at the back end of the program and hopefully finishing earlier than currently planned. So importantly, by plotting a straight line through the project, we've created the right conditions to operate a pull system. Come on to the next slide. Right. So we're on to step 2, create flow via a pull system. So what is flow? Well, being in the flow is the mental state in which a person performing some activity is fully immersed in a feeling of energized focus, full involvement, and crucially, enjoyment. So let's look at how a lean pull system can create flow. I'm sure you've all heard of the game Tetris, and I'm banking on the vast majority of you of having been absorbed playing it. If you have, you would have been experiencing flow. And you may be surprised to know that Tetris itself is a pull system. So I'm going to explain that. The first part of a pull system is triage. This sorts out the order of work that is going to be undertaken. And then when work enters into the system, it's termed work in process. And this work in process is regulated by a completion rate. Now, obviously, Tetris is a game, so it incrementally increases this completion rate for you until the game is over and the whole thing's stacked. You've got pockets of inefficiency in amongst your blocks. And importantly, what happens in the pull system is dictated by human factors. So these are in Tetris how you manipulate the blocks. And similarly, in FlowLedger, you're manipulating tasks as they pass through the pull system. So if you continue with the Tetris analogy, imagine the sweet spot when you're playing Tetris is when you're clearing lines as quickly as the tasks are falling. And the higher up that level you can get and you're still maintaining control over that game, that's when you're in the flow, and that's when a project's doing really well. So that's what FlowLedger is going to be engendering in project delivery. So we treat it like a game of Tetris. As the team delivers the work in process, it constantly reruns the recommendation engine that we've created, and that optimally sequences the remaining tasks. So we're always minimizing the amount of work in process to keep the team focused and immersed in successful project delivery. And the final step, there it is right into the ledger. So in the next decade, business intelligence driven by clean data will separate successful projects from the ones that make up the statistics quoted at the start of this presentation. If we don't do something different, we're going to continue to see 30% project overspend, 40% delays. Something needs to change the status quo. So this is the FlowLedger user interface. And I'm just going to work through all the components that we've just demonstrated in Tetris and how they're applied on our UI. So the screenshot you're looking at here is the full UI open. It's actually separated into windows. The main window is Flow. This is your pull system. So as before, you've got triage. FlowLedger is deciding which tasks are next to be pulled into the system, and it's going to be giving you an idea of when they're next going to be drawn into the system. Sorry, my cursor's in the wrong screen. So here you go. So we know that this top task is due to come into the pull system today. So you can get task ready. Work in process is spinning cogs. The cogs are static. It's waiting to be worked on. All the time something's in the pull system and it's not being worked on, it's decreasing value because there's no value add if something's been sat there being waited to work on. Again, our recommendation engine is actually dictating what the primary objectives are in terms of task delivery. And then finally at the back end here is where we all want to be, is pushing through tasks through to completion. So at the other side here, you've got human factors. The idea with FlowLedger is it's not just a planner running this. You can have the whole project team. In fact, you could have the whole supply chain working on this. You can have various levels of access. You don't have to have everyone working with working access or seeing the full picture. But you do want everybody engaged in what matters. And it's those human interactions with the tasks as they pass through the pull system, which creates the ledger. You've got the ledger in narrative format here. So the solid blue blocks are where there's been a human factor, an intervention in the task. And then you've also got the opportunity to comment on the selected task as it passes through the system. And then in the calendar view, here it is, sorry, you've got when the recommendation engine is forecasting the task is actually going to be undertaken and the delivery window for that. So basically it's the difference in the early start date and the late finish date. Okay. So in essence, what this is demonstrating is a move to dynamic project planning. So the way we currently operate, we do a periodic schedule update, and that's shared with the team. And then there's a reporting period of 4 weeks or a month, and then you do another update of the schedule. We're democratizing this process. We're drawing this information out. Our API is in development at the moment. Drawing this information out, pushing it into FlowLedger. FlowLedger is updating your schedule in real time, and you can pass that back to your enterprise as often as you like. Now, that can be pushed back into Primavera P6, can be pushed back into Power BI. It's making real-time reporting a reality. So, the call to arms is we'd like to reset productivity standards together. We're looking for pilot projects. We're actively looking now. The software's ready to go. So if you're interested in trialing it on the project, get in touch. My email's at the bottom there. We're looking for collaboration partners. And we're also just entering our first funding round. We successfully got seed funding earlier in the year, so enabled us to get through to MVP, and we're ready for the next step. So that's FlowLedger in a nutshell. I could go on. I know we're time bound, but thanks for listening. I'll pass you back to Phil.
Well, you're not getting off that easy because you've got a question here. Let me read it to you. If there are changes in logical sequence or changes in number of activities from initial baseline, which respectively change float and the upper and lower boundaries, how would FlowLedger resolve these issues? Can we read it again?
No, I got that. You just update your strategy. So at the moment, it's a manual intervention, and I think it should remain so because you've got to have control over the project strategy. The master schedule is almost always a contract document, so you're not going to be making incremental changes to your logic without authorization. But the facility's in FlowLedger. You just click upload the strategy, and your latest strategy from P6 or MS Project or Asta will be incorporated in the FlowLedger. FlowLedger will dynamically update. It's got its own critical path method algorithm. It'll update the schedule as progress is entered in FlowLedger. But if you want to make a lot of strategy changes, you need to go back to your planning software.